This type of mechanical stress is the sound of a system in crisis. On traditional mechanical hard drives and older SATA SSDs, this erratic behavior leads to total system unresponsiveness. While it looks like a hardware failure, the actual cause is usually severe background I/O contention. Windows treats idle time as an opportunity to index files and run telemetry, often prioritizing these tasks over your immediate actions. We are going to identify the specific culprits and adjust 4 settings to drop your disk usage back to a healthy range of 0 to 5%. Ensure you have administrator privileges before proceeding, as we need to modify system-level configurations. Reclaiming your disk queue avoids the cost of new hardware by systematically stopping the operating system from suffocating its own resources. We begin by isolating the exact background processes choking the disk queue. Press Ctrl, Shift, and Escape to open Task Manager. Navigate to the Performance tab and click the Open Resource Monitor link at the bottom. In the Resource Monitor window, expand the Disk section. Sort the active processes by total bytes per second and look at the Response Time column. Response times exceeding 100 to 500 milliseconds during light usage confirm a background bottleneck is present. The first suspect is sysmain, formerly known as superfetch. It analyzes your usage patterns to preload application data into standby RAM, often creating a massive queue of read requests that slow down the entire drive. To disable it, press the Windows key and R, type services.msc, and hit Enter. Locate sysmain, change the startup type to disabled, and click Stop. Monitor your Task Manager to see if disk usage immediately settles toward that 0 to 5% target. Disabling sysmain restores immediate read and write capacity. This change has no negative impact on modern systems with sufficient RAM. Next, we address the continuous background scanning loops caused by the Windows Search Indexer. When you have active syncing folders like OneDrive or large unindexed directories, the indexer can enter a constant state of scanning that pegs the disk at 100%. Do not disable the Windows Search service entirely. Doing so will break the search functionality in your Start menu. Instead, we will restrict its scope. Press the Windows key and S, search for indexing options, and click Modify. Uncheck your large data drives, cloud storage folders, and deep project directories to reduce the total workload for the indexer. Restricting the indexed scope makes Windows Search an efficient, targeted tool rather than a resource hog. We now shift to the mechanics of virtual memory and the system page file. An improperly sized or fragmented page file forces the system into continuous, heavy disk swap operations as Windows tries to manage its memory footprint. Open System Properties by typing sysdm.cpl in the Run box. Go to Advanced, click Settings under Performance, then go to the Advanced tab and click Change. Uncheck Automatically Manage Paging File Size. Set a custom size by multiplying your physical RAM by 1.5. Enter this number into both the initial and maximum size fields to create a static, unmoving block that prevents resizing overhead. The final culprit is the Connected User Experiences and Telemetry Service, or DIAG track. It frequently writes small event logs to the disk, which keeps the active time pinned at 100%. Run PowerShell as an administrator. Execute stop service "diag track" -force, then execute the set service command to disable its startup. Locking the system page file size and terminating telemetry eliminate the micro-writes and resizing overhead that disrupt disk responsiveness. Now that we have addressed all 4 areas, we can verify the results. Open Task Manager one last time. The disk usage graph should now show a steady, clean baseline between 0 and 5%. Test the system by opening a large application or navigating through complex folders. You should notice near-instant responsiveness. This restored performance confirms the hardware remains functional. The original freezes were the result of unoptimized background tasks, not a mechanical defect. By taking control of these system processes, you've resolved the 100% disk usage bug and extended the operational life of your drive.